Okay, so we are given that REX, we are given that figure, and we are asked to prove that WER is congruent to XEQ. Now the way we're going to do that is by saying that they both share the angle REX. So those together make 180. Those together make 180. They share this angle. And so if these two angles make 180 and these two angles make 180 and they share that angle, then these two angles must be the same. That's the way it's going to go through on the proof. So REX and XEQ are supplementary because of linear pair. That means that their measures add up to be 180 degrees. Measure of angle REX plus measure of angle XEQ is equal to 180 degrees. The other linear pair that we had, remember we were doing REX and XEQ, so that's that one. We need an angle that they share, so it's going to go like this. We can look below to see it also. WER and REX are the two angles we're using. So, angle WER and angle REX are supplementary. They are 180 degrees because definition of supplementary. Now, because both of them are equal to 180, they must be equal to each other. So we just copy measure of angle REX plus measure of angle XEQ from the top one is equal to measure of angle WER plus measure of angle REX from the second one. Now we say they both have an REX, so we're going to drop that out. We're going to subtract to make that happen. And you can see that we ended up with WER and being equal to XEQ. Their measures are equal, so they are congruent. Angle WER is congruent to angle XEQ because of definition of congruent. Angle A is a right angle because that was given. Angle E is a right angle. That was also given. So the measure of angle A is equal to 90 degrees. Definition of right angle. Measure of angle E is equal to 90 degrees. Definition of right angle. Measure of angle A and measure of angle E are both equal to 90 degrees. Since they're both equal to 90, they must be equal to each other. Measure of angle A is equal to measure of angle E because of the transitive property. And then they are congruent because their measures are equal. That is definition of congruent. I'll pause here if you need it. Moving on. We have angle MUQ is congruent to angle JID as what was given. Let's mark it. We are asked to prove that QUW is congruent to DIH. The way we're going to do that is say, oh look, together these make a linear pair, together these make a linear pair. These two angles are the same, so if both pairs of those make a linear pair, these two angles must also be the same. Here's how it's going to go in our proof. Definition of congruent allows us to change it to be measure of angle MUQ is equal to the measure of angle JID. Now we're going to say JID and DIH are supplementary. That's this pair right here, because they form a linear pair. Then we're going to say their measures sum to be 180 degrees. Then we're going to look at our other linear pair, and we're going to try to name these angles the same way that they are named down here. So, angle MUQ and angle QUW are supplementary. Because they form a linear pair. They're 180 degrees because definition of supplementary. Now, these two are both equal to 180 degrees, so they must be equal to each other. Measure of angle JID plus the measure of angle DIH is equal to the measure of angle MUQ plus the measure of angle QUW. Because of the transitive property, we took both of those statements and stuck them together. Now, this one is a little bit tricky because we have to notice that none of those angles on either side are the same, but the measure of MUQ is equal to the measure of JID. So we can subtract JID from one side and MUQ from the other side because they are equal. That is subtraction. Measures are equal, so they are congruent because of definition of congruent. Okay. Number 4 is very easy. We're supposed to prove that those two make 180. So, angle CUQ and angle QUD are supplementary because of linear pair. So the measure of angle CUQ plus the measure of angle QUD is equal to 180 degrees because of definition of supplementary. I'll pause here if you need it, and then I'm going to move on. Okay, for this one, we are given that UM is congruent to HX and that MI is congruent to XQ. We are asked to prove that HX plus XQ is equal to UI. So if we look at the one on the left, those two are the same as those two over there. So if I add up the two on the left and I add up the two on the right, I should get the same thing. What we're going to do to prove it is to substitute one of them in, substitute both of them in for the other ones in the equation to show that that is something we can prove that they add up to be the same. So UM is congruent to HX is given, so is this one. Measures are the same because of definition of congruent segments, so the measure of UM is equal to the measure of HX. This is also definition of congruent because we went from this statement to this statement saying that they are congruent, so the measures are equal. Anytime we do that, that is definition of congruent. Next, we are adding up UM and MI to make UI, the entire line segment. That is segment addition. now what needs to happen is we need to take this one and replace that one with it, and we need to take this one and replace that one with it. We're going to do substitution twice to do that. So we're going to see that UM is equal to HX. So we're going to replace UM with HX. And actually that's the wrong line for me to highlight. The measure of UM is equal to the measure of HX. So measure of HX replaces measure of UM. Everything else stays the same. Next, we are going to see that MI and XQ are the same, so we are going to, or equal, so we are going to replace MI with XQ. And we can see that what we have now matches what we were asked to prove. One more, GAW is congruent to BEX is what we are given, and we are given that WAH is congruent to XED. We are asked to prove that the two larger angles are also congruent. This is very much like the one above it, but if we add two things that are the same together, we are going to get the same thing. So we're going to start with our two given statements. Then GAW is equal to BEX because of definition of congruent. So then we'll do H is congruent to XE. So measure of angle WAH is equal to the measure of angle XED. Next, we can do angle addition to say that BEX plus XED makes BED. Notice this one here on the right. We're going to do the same thing for this one here on the left. We're going to try to match this naming convention. So we're going to say that the measure of angle GAW plus measure of angle WAH is equal to the measure of angle GAH. Next, we are going to see that the measure of GAW and BED are equal, and that the measure of WAH and XED are equal. So we are going to replace WAH with XED. So measure of angle GAW plus measure of angle WAH. No, that's actually not what I want to do. Let me think for a moment. We need to get BED in there somehow. So we're going to say that BEX and XED make BED. So I want to replace GAW with BEX. So measure of angle BEX plus measure of angle XED equals measure of GAH. So all we did there was replace GAW with BEX. Now we are going to notice that BEX and XED, BEX and XED are the same as BED, and we are going to replace them with BED. That is transitive. I'm sorry, this one here is angle addition or substitution. This one was substitution also. Then we are going to have last angle BED is congruent to angle GAH.